Right, so let's get into this bell work here. So last time we talked about translating a radical into an exponential form. So first, let's review what these vocabularies mean. A radical is another way you say root. So radical means any type of root. It could be a square root, a cube root, a fifth root, a 100th root. But radical is talking about this symbol here where you see the root. Exponential means, well, it sounds like an exponent. So exponential is talking about, when you have an expression in an exponential or an exponent form, or you see an exponent present. And so what we're going to do is we're going to take some number, let's just use x here, and x is to some power that looks like a fraction. So let me use some generic numbers here. I'm going to call m over n. And you can write this as a root is what we learned last time. Basically what you do is take your base. Your base is the big number, and you put it inside the root. And then your number in the top fraction or the numerator is your, what would you call your exponent that goes inside the root. So m will go inside, whereas n is in the denominator, so that's going to act as your root, so n is outside. So anytime you want to translate an exponent that's a fraction, basically the denominator tells you your root, the numerator tells you the exponent that goes inside, and you can easily translate something from an exponential form to a radical form or vice versa. So let's try that out with this one here. You have 6 to the 3/8 power. This 3 over 8 is an exponent. So what I'm going to do here is translate this to a radical. So I'm going to need to have a root. My 6 here is my base, so I'm going to put 6 inside. The 3 here is my exponent, so that's going to go inside, whereas the denominator tells me my root, and that's going to be outside. So it looks like I have the 8th root of 6 to the 3rd power. All right, let's try out this one here. So this one, a lot of people will get this problem wrong, and I'm going to show you the wrong way to do this problem first. So what I see oftentimes is students will see this problem, and they'll take this inside as their base, and they know that that's their base. But then they'll see the 5 and they see the 3 that's inside, and so that's the only exponent that they see, so they write this as 3 over 5, and they're done. But this is actually not correct, okay? So one thing that I do like what students do is they use parentheses. So when you have multiple things inside your root, it's really important to use parentheses to cluster all of that. Because when you cluster them, you can say it's to the first power. Anything that doesn't have a power outside, you can assume it's 1. So because I've clustered this into a parentheses, I can assume that the exponent out here is 1 because anything to the first power is itself. And so I can say, oh, this base here, all of this stuff inside the parentheses, is to the first power, so the first power goes on top, and is being taken the 5th root, so that root here goes in the denominator. And this is the proper way to write an exponent that has multiple stuff under the radical. Because when you write this 1/5 outside, you are saying that everything inside is taken to the 1/5, or the 5th root, okay? If you only give it to this b here and say 3 over 5, you are only saying that the b is being 5th rooted, whereas the others are neglected. And we don't want that. We want to include everybody that's in this root. All right, now that we've gone over that, this would be the final answer. Remember, we're just translating here, so we don't need to simplify. All right, so number 2 here, it says to solve the following equation, or in other words, get the x by itself. So here's the x. The x is almost by itself. But before I do this problem, I want to show you a problem that more people are familiar with. It's this x squared equals, I don't know, I'm going to just do 9 here. So when people solve this problem, generally they notice, oh, I got to get rid of a square. How do I do that? And we learn that we take a square root, right? We take a square root so we can cancel out the root with the root cancels out the square. And so then we get the x by itself, and the square root of 9 is 3, and then we're done, right? But in this problem here, it's basically asking you the opposite. You have a square root and you need to get rid of it. But we just learned to get rid of a square, you use a root. So we're going to do the opposite here. If this is a square root, right, what we do is we raise it to the power that the root is. So if this root is a 2, the power here to cancel out this root will be a 2. So I can cross that out when I raise it to the second power. And because I raise this side to the second power, I have to raise the other side by a second power. And so x comes down as it is because once you cancel out that root, you're just left with whatever was inside. And then 5 squared gives you, well, 5 times 5 is 25. And then there we have our answer because x is by itself. And there we go. All right, so I hope this helps you a little bit with your homework. And then this guy is our superstar for today. We're going to get into something called solving radical exponents, solving radical equations. And so let's see how we solve those problems. All right, so steps for solving a radical equation. So like I said, radicals are another way of saying roots. And you can see here, we do have a root here or a radical here. And we're trying to solve for x. So eventually we need to get the x by itself so we know what x is. So as you can see here, basically I've written some steps on the basic steps for solving something that has a root, okay? So we're gonna start with the first step. And it says to isolate the radical. What that means is basically you got to get the root by itself, okay? Just like parentheses, when you have a set of parentheses, right? You want to get the parentheses by itself. So anything that's outside the parentheses, like the 8 and the negative, we're going to have to remove. So outside here, I have an 8 and a negative. I need to remove this 8 first. So that's pretty easy. All I have to do is subtract the 8 off to remove it. And so now I have a negative square root. X plus 12 equals 3 minus 8 is negative 5. And then from there, I do have a negative sign. So to get rid of a negative sign, I'm going to have to, one way you could do it is just divide by negative 1 is my typical way. So if I divide by negative 1, I have to divide by negative 1 on this side. So I have the square root of x plus 12 equals negative 5 divided by negative 1 is positive 5. And then from there, like I said before, this is a square root. So to get rid of a square root, we're going to square the root. That way we can cancel out the root with the power 2. And then I have to square the other side too. So if you square one side, you got to square the other side. So x plus 12 comes down. 5 squared is 25. Again, very similar to the bell work. And then notice how we got the root by itself, right? And then when I was on this step and the root was by itself, I had to cancel out the radical by raising each side by the equation to a power. Well, that power was 2. To cancel out this root, I needed a second power. If it was the third root or the cube root, I would use the third power to cancel it out. If it was the 100th root, I would use the 100th power. Whatever power or whatever root is whatever power you're going to use. So I've done step 2. Step 3 is to just solve for the variable. As you can see, x is almost by itself. I just need to move over this 12. So I'm going to subtract 12 over. So that cancels, and x is equal to 25 minus 12, which is 13. And so now I have solved for the variable, and this here could be my answer, but notice how step 4 here, in exclamation point, I say check your answers. Because here's the thing. This is a radical problem or a root problem. For some reason, roots are very finicky. Even if you've done every step here correctly, this might not be the correct answer. In fact, there might not be a solution at all that makes sense to the answer that's beside it. So you have to check your answer before you decide this is the correct answer. So I'm going to check my answer here to the side. So to check the answer, all I have to do is take this 13, the x, and plug it in for x. So this is 8 minus the square root of 13 plus 12, and I need to make sure it equals 3. So I don't know if it does equal 3. I'm going to work on the left-hand side and see if it does. So you always want to start with the inside here. So I'm going to take this 13, add it with 12 inside this root to get 25. And then the square root of 25 is just 5. And let me just bring down the 3 as I'm going here. So, and then I can see, oh, 8 minus 5 is just 3. So the left-hand side is 3 and the right-hand side is 3. So this is good. This is actually really good. So that means that this here is the correct answer. X equals 13 is a valid answer because we checked it, we plugged it back in, and we got the same number that the equal sign had. So this is good. That means I can say this is my final answer. All right. So that's it for the journal. In the next slide here, I'm going to be doing problems from the homework. So if you want to stick around and watch how I do those, feel free to grab your packet 11 and try out these problems with me. All right, so here I have packet 11, page 2, so the back side of this worksheet. And I'm going to start us off with number 2. So in the direction, it asks you to solve for the equation. So you have to get x by itself, and you need to check your answer. So in this case here, I'm going to start with number 2, and you can see here the root is not by itself. There's a plus 7 here, so I do need to first remove the plus 7. So I'm going to subtract the 7 off. So that comes off. The square root comes down, and 2 minus 7 is negative 5 on the right-hand side. So again, remember, this is the root is by itself, so what we do to get rid of a root is use the power that corresponds to. So this is a square root, so I'm going to use a square, or I'm going to square it to get rid of this root, and then I'm going to square the other side. So the root and the square cancel, bringing down just x and the minus 1. Negative 5 squared, negative 5 times negative 5 is negative 5 squared, gives you positive 25. So positive 25 comes down. And I'm going to add 1 to both sides. And so then the 1's cancel. X comes down. 25 plus 1 gives me 26. And so it looks like 26 could be my answer, but remember, you got to check your answer. If you don't know for sure this is the correct answer. It might not be a solution that actually works. So I'm going to check my answer. And to do that, remember, we just take the x value, plug it into the equation again. So this is the square root of 26 minus 1 plus 7, and I need to make sure this equals 2. So working inside the root first, 26 minus 1 is 25, which is a nice number to be under a root. And everything else I drag down. Square root 25 is 5. I'm starting to see something fishy here. Notice how this side here, I have a 5 plus 7. If you add 5 with 7, you get 12. And last time I checked, 12 does not equal 2. Okay, so because I already noticed there's a mismatch, I know that this x equals 26 here is not a solution because I plugged this back into the equation and I didn't get this to equal the same side as the equal sign, okay? They don't equal. So in this case, this is a no solution. So it's like you checked your answer, it actually wasn't a valid answer. So in that case, there aren't any solutions that could make this work. All right, so again, it's really important to check because you don't see that coming until you check it. All right, so this one here, I like to bring up because there's an exponent here. So this is an exponential form. It doesn't have a root, but remember those parentheses, you got to get it by itself, just like those radicals. So I'm going to add 4 to both sides first to cancel out the 4. The root comes down, not the root, the parentheses in the exponent comes down. And then this side here is negative 2 plus 4, which gives me a positive 2. Now, this is where people start asking me questions like, Miss Chang, what do I do with this 1/3? Well, friends, on Friday, or on that day we learn about translating radicals to exponentials, we can translate this exponential to a radical or back to a root. So if I translate this to a root, my base here is x minus 5, right? All of the stuff in the parentheses is my base. My root here is actually 3 because that's a number in the denominator. So 3 here is outside. And then this is to the first power that's on top. So I can say that all of this is to the first power, but anything to the first power is itself. So I don't really need to write the one that's in here. So just the root goes outside. In other words, like I don't have to say that this is all to the first power, anything to the first power is itself. So I'm just going to leave that and bring down the 2. So from here, I'm like, oh, this is a cube root. To cancel out a cube root, I need to raise it to the third power, so I have to raise the other side by the third power. Now, I cancel out the roots because those cubes are going to cancel each other out. X minus 5 comes down. 2 to the third power. 2 times 2 times 2 gives me 8. So 2 to the third power is 8. I'm going to add 5 to both sides. That cancels. X is equal to 8 plus 5, which gives me 13. So X could be 13, but let's double check here. So I'm going to check my answer. And I'm going to plug 13 into the equation to work this out. So in the parentheses here, 13 minus 5 gives me 8. And it's to the 1/3 power, and this side should equal -2. So just looking at this portion here, anything to the 1/3 power is like saying the cube root of, in this case, 8 on the inside. So I just translated this 1/3 to a cube root. And then I'm going to drop down the -4. Oops, -4 equals -2. The cube root of 8, you guys probably might know, cube root of 8 is just 2, right? It always takes 3 2's to make an 8, so cube root of 8 has to be a 2. Subtract 4 from it, and if I really take a good look at this, sorry, I'm trying to shrink this, -2 minus 4 gives me -2, and this does equal the right-hand side, so this does check out. So I can definitely say that X equals 3 is a valid answer. All right, so this time we did get a valid answer. Okay, let's do 2 more together. I'm going to do 5, and then I'm going to do 7. So feel free to follow along if you would like some more practice with me. Okay, so in number 5 here, you have 2 roots this time. So it looks like a lot, but it's actually a really simple problem because first off, there is nothing outside of both of these roots, right? So it's like you don't have to shift anything around because there's nothing outside the root. So if I had to just start with this side here, to get rid of a square root, we already know that we have to square both sides. We have to raise it to the second power because it's a square root. But if I decide to raise the left-hand side with a square, I have to automatically raise the second side by a square. And so that cancels out both of the roots when I do that, when I square both sides. And so then everything on the inside of the root comes down. And then once they come down, it's like, oh, this is just a normal algebra problem where I have to get the x by itself. So maybe I'll move this x over to the other side. So I'll subtract x. So that cancels. So that would just be 2x minus x, which is x, minus 7, 2. I'm going to add 7 to both sides to isolate this x, or to solve for x. So x is equal to 2 plus 7, which is 9. And so in this case here, x could be 9, but remember, we do need to check. So to check this problem, I have a square root of 2 times 9 minus 7, square root of 9 plus 2. So if you look back at this, there are 2 x's, so I did plug x into both of those, and I wrote it out here. So working on the inside, on the left-hand side, 2 times 9 is 18, and then I have a minus 7 that drops down. 9 plus 2 is the square root of 11, and then if I do the left-hand side, 18 minus 7 gives me also an 11. And the square root of 11 sure does equal the square root of 11 on the other side. So I'm not going to work it out any further because I already see that they match. And so they are definitely, or x equals 9 is definitely a solution here. So sometimes when people already realize that it's an answer or not an answer, they might just like stop because they can already see what's happening to the number that's being plugged in, whether it's a solution or not. So last one for today, I'm going to try out number 7 with you guys. This one's another exponential. So the question is, here's the parentheses. Do I move over this 2 first that's outside of it, or the 4 that's outside of it first? Well, I'm going to tell you that either one actually doesn't matter which order you remove first, the 2 or the 4, but there is one that's a little bit easier to do. So if you chose the 2, what you would have to do is divide everything here by 2. Because it's a division. To get rid of 2, you have to divide everything by 2. To get rid of 4 is a lot easier because you just have to subtract 1 time the 4 on both sides. So if I subtract off this 4, which would be the easier route, I only have to do it 1 time on either sides. So then I'll bring down everything. So subtraction here is a little bit easier. 0 minus 4 is negative 4. And then I have to divide both sides by 2. So the 2's cancel. And then I have x minus 10 equals, x minus 10 to the 1/4 equals negative 4 divided by 2 is negative 2. Then from there, I do need to change the 1/4. I'm going to change the 1/4 to a root. So this is a 4th root because the bottom here is a 4. So this is a 4th root of x minus 10 on the inside. And again, I'm not going to write the 1 here because this would be saying like, oh, I got to take this to the first power, but the first power is just itself. So that's a little redundant. So I'm going to get rid of that. Negative 2 comes down on the right-hand side. So I can see here, I do need to get rid of a 4th root. So I'm going to raise it to the 4th power and raise the other side by the 4th power. So the roots cancel with the power and x minus 10 drops down. Negative 4 to the 4th power. Negative 2 times negative 2 times negative 2. So 4 times. So negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. That's a positive 16 right there. Then I have to add 10 to both sides. That cancels. And x is equal to 26. Now, again, I don't know if this is the correct answer, so I am going to check. So if I check my answer, that's going to be 2, plug in 26 minus 10, 1/4 plus 4, and I need to make sure this equals 0. So if I work on the inside here, 26 minus 10 is just 16 to the 1/4, 2 outside. But if I look inside here, I need to take the 16 to the 1/4 power, or that's another way of saying the 4th root of 16, right? Because in this case, the denominator is 4, so I know this is the 4th root of 16. The 2 comes down as it is, and I'll multiply that with the 4th root of 16. So the 4th root of 16, what number multiplied 4 times gives you 16? Well, I just saw that a moment ago. Apparently, it's 2. Right? So this is a positive 16. So in this case, I'm just going to use positive 2 here. So I'm going to use a positive 2, bring down the other 2 and multiply it. But I'm starting to notice things. So I'm just bringing down the right-hand side as I go. But 2 times 2 is 4. 4 plus 4, I don't think this is going to equal 0. 4 plus 4 is 8, and 8 does not equal 0. So in this one here, definitely, again, not a solution. This is going to be a no solution because we got an X, we tested it out, failed, got an invalid answer, so this is no solution. And that's it. So I hope this helps you out with figuring out the rest of the homework problems. So I knocked out 4 of them for you guys. Hopefully that gives you some example to look back at. And again, make sure you check those answers because you won't know if it's a valid answer until you've checked it. All right. Until next time, guys. Bye.